In our last lecture, we talked about excitation-contraction coupling. Today, or with this one, we're going to talk about the sliding filament theory. I want to make it clear that this is just a theory of how this process occurs. It's not complete, it's not perfect, but it's one of the best explanations we have to explain how muscle contraction occurs. I also want to make it clear that there's new information that we're going to talk about in the next lecture called the winding filament theory that kind of takes what we've understood for a long time with the sliding filament theory and it adds a little bit more information. So remember, this isn't the end-all be-all. This is just what we understand and how we understand muscle contraction works. This can always be difficult to understand these things because they happen on such a small scale, right? So it's not like it's something we can easily visualize. So here we go. We're going to summarize the sliding filament theory. We're going to identify what is needed. And just so we're clear here, most all of these slides are essentially right from PE 220. So if they look familiar, that's why, just because this is a review. So remember, calcium enters the sarcoplasm, which allows actin and myosin to bind together tightly. Okay, we call this the rigor state. When a myosin head is bound to an actin fiber, we call this a cross bridge. And in order for a muscle to contract, myosin pulls actin. Then actin has to detach from myosin. Then myosin and actin have to reattach. Myosin pulls actin, and the process repeats itself several times. So in order for this to happen, we need ATP. Remember, as we go through this process, that ATP and its products are the cause, and whatever happens to actin and myosin is the effect. In other words, something happens to ATP, which will cause something to happen to actin and myosin. So at this point, actin and myosin are bound together. So as you can see, an ATP molecule binds to myosin, which will then cause actin and myosin to break apart. Cause ATP binds to myosin, effect actin and myosin separate. Once bound to the myosin head, ATP will be broken down, which releases energy. And we can see that, with this little explosion here. And so this release of energy causes the myosin head to cock, which allows actin and myosin to bind. So the breakdown of ATP and the release of energy is the cause. The cocking of the myosin head is the effect. Next, phosphate is released, which causes the power stroke or the pulling of actin towards the M line. Cause, phosphate's released, effect, power stroke. Finally, ADP is released, which results in the tight binding of actin and myosin. And this process will continue and the muscle will shorten as long as there are three things present, which are acetylcholine, calcium, and ATP. If any one of those things is not available or is missing, it will be very difficult, maybe even impossible, for successive muscle contractions or successive cross-bridge cycles to occur. So, that's it. Nice, quick, easy review. So, can you do the following? Can you explain the process of cross-bridge cycling? And can you identify the three things that are needed for successive contractions?